Please welcome him. Thank you, Ruben.
Hello, ETHDenver. I am representing Hexons, and I am Chief Information Security there. And I would like to introduce you to a few projects that we have started and just a small history that we had. We are doing cybersecurity for the last 13 years. We have started our products this year, and one of the products that I will be presenting now have started just yesterday. So what do we like and what principles we follow? The first and the most important one for us is that we like community really well. We run our Vulnerapedia. It's a Wikipedia devoted to the Web3 security issues, listing all the possible bugs, the most prominent hacks, and stuff like this. And our idea and our approach is that Web3 security is often understood or is being seen as something luxury. And we would like to bring to the community the idea that it is not luxury. So we have created a platform that is called Remedy. And what is there? First of all, all the listings or Remedy are free for now. Next is that bug bounty service fee is again zero. We are not going to charge will it be projects or will it be security researchers for any found bug or payment. We will provide security triage for all the reported bugs to minimize the conflict of interest between security researchers and security projects that are being listed in bug bounty. We provide assisted migrations from different platforms, different bug bounty platforms coming to our platform. We are not doing exclusive contracts. I mean, if a project wants to be listed in Remedy, it could be listed everywhere else. And we are providing free access to Glider. And before I will show you the Glider, I would like to tell you what are the problems that we were trying to solve and what are the foundations that we are trying to build that product on. The first thing is that key smart contracts in blockchains are open source. I mean, feel free to take pictures, guys. What is good and what is bad in having open sourced key contracts? The sources are available to white hats and to black hats. So white hats are doing security research for good, and black hats doing the same security research for stealing assets. Next thing is that common mistakes, and there are nearly 20 types of different bugs that could be implemented in smart contracts that we can find in smart contracts. All those bugs are really common. People know how to program securely for decades, but no one cares about it. It's like 10 Commandments. People know about 10 Commandments for 6,000 years, and no one cares up to now. Smart contract code is often reused. And if a bug is found in a smart contract, then it is being fixed. It is not being fixed in all the derivatives of that smart contract and the reused code. At that point, we understood that during our security research or smart contract audits, we are dealing with the same bugs all over and over. And we have tried to find a way to build a lazy auditor's security tool. Something that will allow us to find bugs en masse on the whole blockchain. So what do we decided to do? First of all, at least for now, there's no automation in bug hunting. We can say that there is some approaches with LLMs or any other AI appliance, but for now they provide more false positives than real findings. if you are following Immunify or any other platforms, you may see that there was a shitload of false reports starting like 2023 February, because people were putting smart contract code into ChatGPT and trying to report something that ChatGPT found to bug bounty platforms. And of course, the increase was like 24x of reports. And all those 24x of reports was nothing to do with real security findings. Even when AI, and I understand that it will be the day when AI will cover security issues, even when it will cover, it will still remain a human job. It will remain a job that should be done or authorized by humans. Of course, there would be a lot of false positives, and at some point we will be going through those false positives to find something relevant or something efficient. But at that time and in near future, near perspective, and when I say near, I mean 3 to 5 years, I do not see AI reaching a normal proof of concept for reported security issue. Another thing is that there's a lot of approaches on how to do security research en masse, but main thing is that people try to find a way to do that common def. And common def is something that is the clearly visible path, but path that will not work. And at least for now, ChatGPT is doing something like this. It is not going deeper into the understanding how Solidity EVM work, and they do not provide efficient enough approach to that task. What do we know? And it is the most important thing, that vulnerable code can be easily patternized. When we say that we have an approach to type of vulnerabilities like reentrancy, like code reuse, we understand that we have that part that it could be patternized, and we have tried to build a solution that will allow researchers to patternize that stuff. What do we address? First of all, and the most important, we are addressing CFGs and DFGs, code flow graphs and data flow graphs. And another approach to this is that we were trying to find a way to describe a vulnerability in a formal language. So here's the glider. First of all, we have compiled a database of all verified contracts. As I've told before, all the critical, all the important contracts, all the contracts created by big projects or big organizations are open sourced and verified, just to tell the audience that they are doing only good and their approach is pure. The second part is that control flow graphs and data flow graphs is something that we would like to build our patterns on. Next thing is that semantic analysis in line with CFG and DFG and Solidity artifacts allows us to come closer to that formal description of Solidity vulnerabilities. And at that time, we have understood that we have to create a query framework that will allow users to query the database, the created database of available compiled smart contracts, and find what do they really need. A side note about source code and bytecode. There are a lot of approaches trying to analyze bytecode in blockchain. The issue with bytecode is that even when we are disassembling that code and trying to get disassembled code, we are losing the logics that developers have put in it. So analyzing bytecode is something that we have tried. We have thought a little bit on it, and understood that it will be more efficient to go into the source code part and analyze source code by itself. So this is the first screenshot, and I would like to give a pause for you just to let you read comments, because comments are self-explanatory. By the way, take pictures. So running this query allows us to look only in functions that have no properties, that have no modifiers, then going into instructions and looking for self-destruct solidity call. What does it mean? It means that we can find with this query all the contracts that have self-destruct function call without proper control. The next one is more complicated. So here we are going, do you see the code or no? So come closer, it's the only thing that I can say. Guys, here we are looking for we are going through two functions that have no property of, that have external and public properties, that have no properties with modifiers and constructor. Then again go into instructions and limiting, calling the function name self-destruct, then limiting the output to 100, then going to again to the results, and through all results we are pushing the global, asking if they have global data flow, then going to previous instructions and looking in those previous instructions conditional comparison, ifs. And after this, we are getting the result of that. We are getting address of the smart contract, and we are getting all the smart contract code that is defined and described by this query. So please scan this QR code, because under this QR code you will have like 1 hour video describing all the technology behind this stuff and how to use this stuff and what can you use and what benefits can you get out of this. It is deeply technical, it is really nerdy, but this product is nerdy and the task is nerdy. So let's move on. Who needs this? First of all, independent security researchers, and I would like to open a little bit what do we want with this stuff. You can search for a bazillion of contracts just with one query. You can define scenarios that will be boutique for your researches. You may focus on delivery of results of really narrow field of your security research and address this stuff through the bazillion of contracts. We plan to collect queries provided by a community in our platform and pay royalties for the bugs found with those queries. So if you have written a query and then that query found a bug in a contract that was deployed after your query, you will still get the royalty for this. You will be able to provide really tailored and boutique services. If you are specialized, for example, in reentrancy attacks, you may go through the database of all contracts and focus only on the type of attacks that you are specialized in. So you will be able to get the lowest hanging fruits and to get this in a bug bounty platform integrated to this stuff. Moreover, we would like to inform, and we will announce it, that the platform by itself will try to find the owners of vulnerable contracts and establish a communication between a security researcher and the owner of vulnerable contract. Scaling. Guys, being in this business for more than a decade, we understand that so far this stuff is still human job. It is not automated. It is not optimized. You are still looking in a source code and trying to find a bug. With this, you may scale your job. Guys, you may divide the job of auditing the contracts between people with narrow specializations and provide them the ability to go deeper into the details. And yep, passive income, something that every computer scientist dream of. It is something that we have tried to provide with this solution. Academia. And we would like to focus on the following thing, that there is a lot of research done by companies and businesses, but we have to understand that universities, independent researchers, have to have the ability to work with the perfect tools, the cutting-edge tools, just to try to find something that is in the blockchain, and the most important, the unknown unknowns. When we are getting a smart contract to audit, we understand that we have known unknowns. We know that there are bugs. We would like to find those bugs. But there are cases when we have no idea what can we find in a research. So research is always dedicated to finding an unknown unknown. And this is something that we are sure that Glider will provide to academia. And one of the narrow benefits of Glider is gas optimization. Because when you are familiar with CFG and DFG approaches, and you may query this through the Glider, you may understand, for example, how to benchmark your smart contract against others' approaches and how it will work deeper. Businesses, Web3 projects will have the opportunity to insert or to use Glider in their CI/CD and CI/CD pipelines and SDLC approaches. Just imagine that you are writing a Solidity code that is being checked against a known database that will be checked against a database of known vulnerabilities. So you will easily find a vulnerable pieces of code, snippets of code during the development, real time. Threat intelligence. We are now developing a dashboard, a SEM-type dashboard that will allow Web3 projects see what happens with their blockchain in terms of written queries. We can provide them service of periodically run quick query sets and understanding what new artifacts have been discovered in their deployed codes. Audit companies, as I have mentioned before, they can scale their business, they can find bugs en masse, they can use this stuff to win their bounties on hackathons and CTFs. They can manage already developed quick queries just to provide that boutique services as they try to build their service on. And create unique checks and estimate the amount of code or amount of, right now, when you ask for audit, the audit company says, okay, guys, what is the amount of code that we will need to audit? And people saying, answering most probably in lines of code, SLOCs or LOCs. In this case, they can provide more precise understanding of what the contract is and how to measure the effort to audit that part. Venture capitalists can use this product for technical due diligence. We can use this product for quick check for security issues before funding. May use this for prediction and analysis of market movements based on code reuse. And Web3 foundation chains may use this for one-day protection, research and development, data extraction, forks, DEX, and etc. And actually understand that Glider is a data mining tool, not a security research tool. So its use is limited, guys, only by your imagination. So I know that there are a bazillion of questions. I will be enjoying my cigar next at that place. So we will have 1 hour of me doped by nicotine answering all your questions. We will have happy hour. Please join our table and ask for this stuff. And please scan this code to see all the resources. Thank you so much.